Good morning, good afternoon, good evening, folks. Thanks for joining us again for another session of the Machine Learning Community Stand-Up. I am your host, Luis, and with me are my co-hosts, Bree and Jake. And we have our guest here, Nicola, who's going to be talking to us about ML.NET and a whole bunch of other fun things. So, Nicola, would you like to introduce yourself?
Yeah, sure. Hi, everyone. I actually had it in my presentation. So my name is Nicola. Thank you guys for inviting me here. I am having a couple of years of experience in working with machine learning and a lot of experience with software development. So I'm basically a software developer going data science and machine learning and AI and all those stuff. So yeah, I even have a book about it, Deep Learning for Programmers, which is basically my experience written down in one place. So yeah, I will speak, I guess, about all those things a little bit later. Yeah, so that would be all. Thank you for inviting me.
Yeah, no, we're happy to have you. Thanks for joining us. We've actually talked quite often about all the work that you put in. You mentioned that you wrote a book, and we can kind of tell because you're putting out a lot of blog posts and written content out there that we definitely like to highlight on this stream. So yeah, thanks for being on, and thanks for putting together all those different guides. One of which we'll be talking about in a bit right now with our community links.
And I don't know if Louis said this yet. Nicola, he is Rubik's Code. So every time we mention Rubik's Code and accidentally say Rubik's Cube, that is Nicola's work.
I know. That's fine. Thank you.
Yeah. Awesome. All right, let's get into the community links here. See here. Switch over. All right, cool. So this is, I'm going to paste it into the chat. Actually find the chat. This is the URL list or the link, the community links that you can access everything that we're going to be talking about today. First off, we're going to kick it off with this virtual ML.NET community conference. And essentially, it's going to be happening the 7th and the 8th of May. So time is quickly coming on for this conference. So make sure to register, first of all, if you want to attend and you want to check out all these, all of the interesting talks. We've gotten quite a few, and we're really excited to share those with you folks soon. And if you're interested in giving a talk, there is the call for papers. So if you want to go ahead and you have a presentation that you'd like to basically give at this conference that is ML.NET related, you can kind of go to Sessionize here, click on the link here. You're going to see that April 11th is the last day for you to submit a proposal. And the types of talks are really have a variety of topics as long as they have ML.NET somehow baked into it. We'd love to hear from you. And basically, if it's tooling related, if you're doing anything like MLOps, let me actually zoom in. It might be a little hard to see. So if it's MLOps related, if you've actually used ML.NET to solve any problems within your business or organization, or even personal projects that you're working on, that would be really great to hear. Interactive computing, right? So if you're working with Jupyter Notebooks, I think we're going to see a little bit of that later that Nicola's going to show us. If you've done contributions or you've worked with big data, whatever it is, any of these things, as long as it's ML.NET related, we'd love to hear about it. So definitely check this out and then go ahead and submit your sessions before April 11th, which is a bit less than a month away. So we're really looking forward to hearing from you.
Yeah, we've already got a few really awesome looking sessions submitted, including I think one is with Xbox, one is with drones. It's really awesome. So we're looking forward to seeing any other talks that you submit and the creativity of them.
Totally, yeah. And if you would like to hear more about it, our friend here, John Wood, actually did a, wait, is it? That's not John.
I was like, who dat?
I was like, yeah, who is that? So John Wood, he went ahead and he did a live stream and recorded it for folks and just kind of talked about some of the things that we just mentioned. So if you'd like to, go back, you can either watch the recording of this stream or you can check out John's video here that he did talking about the community conference and he gives additional details on there. So yeah, make sure to check this out if you like additional information as well. Speaking of updates and things that are happening, this blog post just came out recently on what are the updates to ML.NET and Model Builder in general. Now, if you folks remember or you attended the last stream, we did a few demos of upcoming features. And one of the things that we mentioned, excuse the siren in the background. One of the things that we mentioned was the ability to sort of sign up for this preview. So if you want to go ahead and try some of these things like config-based training and having advanced data options and trying out the new consume step, how you can go ahead and consume models that you train with ML.NET, specifically with Model Builder. Make sure to check out the preview here and try it out for yourself. So one of the things that config-based training images provide you is the ability to basically save your state. So previous to this feature being added, if you closed out of the wizard or through the guide that sort of takes you through the process of training your machine learning model, your state will not be saved if you want to come back to it, if you want to tweak something, right? With this config-based training and the code behind files, you're able to sort of do that, and you're able to go back to a previously saved state. Among other things, there's a few changes regarding the consumption and training of the code, right? If you are curious as to what that config file looks like, it's basically a JSON file that has things like what your data source is, what are your columns, and the basically the what the purpose of the columns are, what sort of environment you're training, and other different things that you can either manually change them here or change them in the UI, right, the Model Builder. There's more things here about advanced data options. The consume step is redesigned here, where you're able to, previously a console app was added to consume your machine learning model, but now you have the option, right? So you get to choose whether you want to add that or not to your solution. Among other things, ML.NET 1.5.5 was released, which brought a few changes, mostly around the deep learning and interoperability features like Onyx, right? So make sure to check those out. And again, there's sort of a call out to sign up and either submit your talks or sign up for the conference to attend. There's a few things that we are looking for feedback on. One is sign up for the model preview, Model Builder preview, to try out the features that just are highlighted in this post here. Also, if you're interested in CML.NET, I know that often we hear on stream and from folks that we talk to that ARM is a really big ask, right? Especially for those Xamarin folks who are Xamarin developers and would like to use ML.NET and add machine learning to their mobile applications. So there's I believe there's an issue on here that you can comment on and provide your feedback as to whether this is something that you'd like to see and things that you'd like to see and the platforms that you'd like to see ML.NET running on. There's also something that we're going to show off in a bit, or we'll discuss later, is notebook experience. There's this issue here. So if you are interested in seeing, so currently, and Nicola's going to kind of show us in Visual Studio Code how you can use Jupyter notebooks or notebooks, .NET notebooks in Visual Studio Code. If you're a Visual Studio user and you would like to see that feature or have the ability to work with .NET notebooks in Visual Studio, definitely make sure to comment here in this issue here and give your feedback. What works for you, what are your workflows, things like that. We'd love to hear what that looks like and see what that looks like, so that perhaps we can start building an experience around that if there's enough interest there. And then finally, there's something that we've talked about for a while, which is when building web APIs, how can you build a minimal version of a web service that exposes your model? There's a blog post on this as well. So if you like to build one yourself using sort of a minimalist type of approach, while still using the ASP.NET patterns, try it out yourself and give us feedback on whether this is something that works for you, or if what are ways that we can improve on that. All right, that was a significant amount of updates there, which is awesome. Speaking of Rubik's Code, here is, not now, but that's cool. If you haven't tried vertical taps on Edge, I highly recommend it. Okay, so machine learning with ML.NET, and this one is the recommendation systems. And let's see here. I know that, oh man, we couldn't use the penguins data
No
set for this
penguins.
one.
Yeah. No penguins this time.
There's no penguins data set for folks who
Yeah.
maybe the first time have not seen our previous streams where you highlighted Rubik's Code or Nicola's blogs here. There is a penguin data set, which Nicola will probably talk about a little bit later, that is basically throughout all the blog posts except this one. But if you're interested in learning about ML.NET and recommendation systems, make sure to give this guide a look and check it out and learn. Nicola does a really great job of explaining not only the technical components of it in terms of what do you need to do to build one of these solutions, but also some of the concepts behind them, right? So make sure to give that a look. Over at Apex Code, I believe in the previous stream we covered part 1 of their machine learning 101, sort of an introduction to machine learning with ML.NET, and they have since published parts 2 and 3. And in this case, they kind of go over some of the context, like ML context, and how you might want to go about basically getting some of the parameters when you train a model, and how you might want to go about building a training pipeline, right? As well as evaluating your model, and something that's very important and you see this often in very highly regulated environments, which is the ability to interpret your model. And ML.NET provides this permutation feature importance feature that allows you to determine what are some features or what are the inputs, right? In this case, temperature seems to be, for this particular model, the one that has the greatest impact on the predictions, right? So that's part 2. And then you can also see part 3 here, which is basically how you can go about and consume a model. So they take you all the way from building a model all the way to putting this model into production. And in this case, right, they're using the prediction engine pool, which is something that we recommend, especially for multi-threaded environments. The prediction engine pool is highly scalable and thread safe, especially for web applications. So make sure to give that a look. They also go into deep learning here. If you are a desktop developer, though, and you work with WPF, you can take a look at this guy from Gerardo here, who goes through and builds an object detection application using ML.NET, and it's a WPF app that you can take a look at. And he basically uses custom vision. In this case, it appears. And so for folks who may not be familiar, custom vision is basically this service that Azure provides as part of cognitive services that allows you to be essentially build your own machine learning model, your own custom machine learning model. Now, ML.NET has an ability to do this, but one of the really neat things is that if, say, for example, you were to use something like custom vision, right, you can export your model to Onyx, and because ML.NET supports scoring with and making predictions with Onyx models that may have been trained elsewhere, right, you're able to take the image classification model that you've trained. In this case, it's an image classification model. An object detection model that you've trained, and use it inside of your ML.NET application. In this case, right, it's being used inside of a WPF app. So if you're interested in object detection and building that into a desktop app, make sure to check out this post here. In other solutions, it seems that version 1.0 is out of the Baseball ML Workbench. And Bart here, who he was on one of our previous streams, basically builds this Blazor application that has an actually, I believe it's multiple ML.NET models running inside of this application. And one of the things that Bart kind of, I think, tries to showcase here, essentially what this does is it tries to, if I remember correctly, it tries to basically determine, what is the likelihood that a particular player, given their statistics, would be able to make it into the Hall of Fame, right? And then he has different scenarios. So it's using something like rules engines, right, where you're basically giving it a certain input, a manual input, right? So if you were writing rules, not really using AI or machine learning, you can do that. But then he also goes into the different ways that you can use either one model, multiple models inside of this application. And some of the things that are highlighted here is, number one is using Blazor, right, to build these and host these machine learning models, and particularly, and I don't know if this particular version of the app is using it, but one of the things that Bart also shows is how you can use Blazor WebAssembly to host your applications. And what Blazor WebAssembly gives you is you're no longer sending requests over to, say, a server to process your requests and make predictions. You're doing everything on the client side and using the client's resources locally to make these predictions. So it's really, make sure to check out this solution from Bart. And this is the code, and you can go ahead and check it out, the actual running application here. If you're interested in learning more and seeing all the blogs that we've mentioned in previous streams from Nicola and Matt, I will turn it over to Nicola to walk us through some of the work that he's been doing with ML.NET.
Okay, thank you once again. Amazing set of links. Basically, that BART solution that he did is amazing. I'm recommending everyone to watch that out. Basically, it's a complete .NET stack along with ML.NET, so it's pretty cool. So yeah. Sure, if you're someone from Marvel and you need a new superhero, so yeah, it's a funny picture. Some of my courses that you can see are written here, and as I mentioned, I've written a book, so you can take a look at it if you're if you're a programmer or software developer and you want to get into deep learning, you can check out my book. Basically, I've written down my experience of how I did it. So yeah, that would be that. Enough of self-promotion, right? So today I'm just going to show a little bit about data preparation that I have done for some of my blog posts, and also I'm going to show you what was my approach in the articles. So basically you can see that in almost every article that I've done so far. It has similar plan and similar solution to it. And I'm just going to talk a little bit about what I'm working on right now and how I'm planning to use ML.NET for that purpose. All right, let's go to Visual Studio Code. So here's my solution for the random forest binary classification. It is something that's available at my blog, so you can check it out there as well. And yeah, basically what I wanted to show is that you can use Python, actually Jupyter notebooks in Visual Studio Code, which I didn't know basically until last week. So I tried it out and it works really well. And you can hear, like, if you're familiar with notebooks, you know you have like this concept of cells, which can be either code cells or markdowns. Here is a markdown field, which is just simple text. So it's a really cool way to build your experiments and stuff like that in a form of like documentation at the same time, so like mini blog posts. And yeah, I'll just use Python really quickly here, but you should know there is also C# interactive, so you are able to, or F# if you're into it, so you can do that with these languages as well, which is really interesting. So yeah, here are just some libraries that I imported for the presentation here, and here is the famous data set with penguins, right? So it's essentially like everyone uses Iris Flowers data set for their presentations. So I decided to use actually this one because it's not used so much, and it's pretty simple. There are just several features in this data set. The first one is species, and it's essentially what our target is. So what we want to usually do some sort of classification. And there, just like in the Iris data set, there are 3 classes of penguins. So there is this Adelie, there is Gento, and Chinstrap. I'm sure I'm butchering that, but yeah. Anyway, there are 3 species, and then there are just couple of features, like from which island do they come from, what's their common depth and length, and their flipper length, and their body mass. So yeah, it's a simple data set, similar to the Iris data set, but it's like fresh and new and fun. And there are like some samples, some examples that don't have data, which is also good if you want to practice like some kind of data pre-processing and cleaning up data. So here I've just loaded that data set, and I basically dropped all the feature except the common length and common depth, because that is what I based my examples on. So once you do that, I just wanted to show you basically how that data looks like when you present it in like this space. So here you can see that this is a Delia, this is chin strap, and this is Gen 2 class. So this is how they are, like in this vector space, would be presented based on common depth and common length. And yeah, since I want to show you binary classification with random forest today, I just modified this data set a little bit. Basically, for every, I just wanted to see if I'm having a Delia class or non-Delia class. So basically, that looks something like this. And if I load that data set, it's much more simple and cleaner. So I just cleaned it up manually. Basically, there are only three features, so species and our target, our output, and there are two features, input features like common length and common depth, and that is basically the data that I use, and here it is in a CSV form. So yeah, that is how it looks like. Now, if you take a look at my blog post, sorry, just a moment. You can see that they are following pretty much the similar pattern, right? So there is this machine learning folder in which I put a lot of things in, and data models, predictors, and trainers are loaded here. So yeah, I will go back to my presentation so I can show you here how it looks like. Essentially, my idea was to create some kind of trainer base class, which is like an abstract class that separate training classes can inherit and do their own like data processing or load their ML.NET algorithm. And then once they do so and they train the data, they can save that model in a file, and you can load it with a predictor class in, you can do that even in another scope. So for example, you can have one microservice which is doing this part, like doing the training of the model and maybe testing the model, and then you can just save it and use different microservice which can use this predictor class to use actually that model, to utilize it. So that is what I wanted to show you. Yeah.
Sorry to interrupt you there, Nicola. So before we kind of move forward, Fire Ice here asks, hi, Panda Python. I believe that they're referring to what you start off with in your Jupyter Notebook.
Yeah.
That's what you were using in your Jupyter Notebook. Okay.
Yes. So basically, this is just Python. This is Python here. So I use that because they have this matplotlib library, which is pretty easy. Actually, I know how to use it, so it's easy for me, right? So I use it for this data visualization, so you can get better feeling of what am I doing with data here. I hope I was not too confusing.
Gotcha.
Yeah. Okay.
Yep, that makes sense.
Okay, back to this. So I'm just going to first go through the trainer-based interface and trainer-based class. So you can see, because majority of the code is done there, and then like trainer classes are doing like smaller tasks, right? They are not so large. They're basically just creating an object of proper ML.NET algorithm. And yeah, you will see that in a minute. So here in the common folder, I'm having this interface, which is, basically just a simple interface. So iTrainer base class should have this name, where we will define the name of the algorithm. We will see how we use that in a bit. There is this fit method, which is like a training, which is usually how people in data science world refer to in training, because you fit your model to the data. And then there is this evaluate method, which will return us binary classification metrics, which we'll use a little bit later. And then there is this save method, which should save the model in the hard drive. So save it on the disk.
Could you zoom in just a little bit?
Yes. Sorry. Oh.
No, you're fine. Awesome.
Now?
I think that. Yep. I think that looks better. Thank you.
Okay. So yeah, here is this trainer base class, which is basically implementing this interface, and it's a template. So it's an abstract class with this template for parameters, and we are using these parameters to create this like a more general, to be more general, because every algorithm, even ML.NET has usually has these separate parameters that it receives. So I've done it this way, so I can like create sort of auto ML thing, but like with more, easier for me to use it. Yeah.
So let me ask you something here. So is this trainer base and the interface iTrainer base, are those part of ML.NET, or are those things that you are that you built yourself?
No, these are actually things that I've built myself. So I wanted to extend. Basically, you're having like ML.NET tooling that you can run your data on. So I kind of did that here in a certain way on my own. So but the goal of this is be able to add like different algorithms if ML.NET supports. So like, I don't know, a new algorithm for decision trees, right? I can easily extend my solution with it, and my like training process can be intact, while I can add another algorithms without any problems.
Gotcha. Thanks.
It will be probably much clearer. I can show you in the program how that looks like. So in the program, I actually create different objects. Go this, and if you have any other questions, I hope that I answered your question. Is it more clear?
I don't know if it for everybody else. For me, you kind of went out when you were explaining the program.cs. Your audio sort of went out. So could you repeat
sorry.
that, please?
Can you hear me?
Yeah. No, we can hear you. It's just that during that part where you were explaining the program.cs, your audio sort of cut out.
Yeah, so I will go back to this program CS, but essentially what I wanted to say is that I tried to create separate instances. So it is sort of AutoML, but it's like I'm using my own hyperparameters here for each trainer. So and then I ran the training process on each of these trainers. So that was the idea behind it, to kind of automate it. And if you have like, I don't know, a new random forest implementation in ML.NET, you can easily extend it and add it here, and you maybe get better results with it, and your tests show that you want to use some other model, right?
Gotcha. Thanks.
Okay. So here in the trainer base, basically some of the things which all trainer classes are using. So here we're having like a model path. This is where I save my model, as I mentioned, ML context, and then I'm having this test train data split. So basically, I will load the data, split it in train and test data, and then use one part of the data for training and the other part for testing. Then here is the model. It is protected, so the classes that are inheriting this trainer base class can override it and put a new instance of this here. Then there is, and here is the train model, which we can use for evaluation later on. So yeah, the constructor is just creating an instance of ML context, and yeah, I can go here in the fit method. So fit method is used for training. It receives the training file name, so actually the path to the training file. We will pass this CSV file with the binary classes of penguins there. So yeah, we will use that like that, and then there are several basically functions that are called within this method. So the first one is probably that I should show is the load and prepare data, where we actually load that CSV file. Here it is. It's a private method. So we are using ML context and load it basically from that text file. And we are using this Palmer Penguins binary data that is located here. As if you used ML.NET API, you probably know that you have to model your data, right? And not in a sense of machine learning, but you just need to put it in some kind of classes. So here is like for our input data. So here is how it will look like. So we are having just common length and common depth, and we are having a label, which is the class of the penguin. So here is the prediction class, which will be the output of our machine learning model.
So just to clarify something, so I noticed that you had that load and prepare data method as part of your trainer base, but you also did some data preparation in Python with pandas. So how is that data prep different from this load and prepare data?
Yeah, well, this preparation that I've done in Python is just to reduce some stuff for because in here we are having 3 classes, right? So I just done that before I boiled it down to 2 classes before I went into the ML.NET. And you're right, I could do that as well here. And where am I? Yeah, here in this build and process pipeline. So I could use transformers and yeah, modify that data. However, I used it before it, and yeah.
Gotcha. Thanks for clarifying that.
Yeah, it's a good question. It's definitely something that I could improve in my examples. Thank you for that. So yeah, so the first thing is basically calling this load and prepare data here in the fit method, and then there is this build data processing pipeline, which we just mentioned, and this method is in here is just concatenating these input features, and I just used normalize min max. So it just normalizes that data. And it also, I added the cache point here, the checkpoint here. Once we've done, so basically in the training process, we first load the data, then we prepare it for the training, like data process pipeline, and then we just append a model to that data processing pipeline to have like this training pipeline. So the idea is basically this model, which we could see here, is going to be overridden with classes that are inheriting this base class. In this situation, it's just one, so it's just random forest trainer. So this trainer, once it inherits this class of trainer base, it just sets the name and it sets the model to the fast forest algorithm, which means that basically in our trainer, when we call this trainer base, when we actually create the instance of that random forest class and we call this fit method, this model here will be the model from here, right? It's this one, fast forest. So so that is how we create. That is how I actually created the training pipeline here, on which I can just call this fit method, which will use the training data set. And evaluate method is much more simple. So it just uses this test data set, and we just call it evaluate non-calibrated here for the binary classification. And as a return, we get like some specific metrics of our of this machine learning model. Finally, the save method is just a wrapper, so it just calls this save on a trained model. So we put it in a model path that we defined up there. And yeah, since I already talked the base class and I show you the random forest trainer class, the only thing that's left is basically a predictor class, which is the other part. So technically, if you're building, for example, some more, let's say, microservice-oriented system, this class can be in your microservice that is consuming the model, which is running the predictions. So here we are again having a model path, and we are having the ML context. So here what we are doing in the predict method of this class is first we load the model. So we check out that if file exists, we use just a file stream to load it into into our model model field that we have here. And then once that is done, we create the prediction engine here using that model. And finally, we call the predict method on the new sample, which is added, which is injected within this method. So yeah, that's pretty much all you need to know about the predictor class. So I talked a lot about there what should be done. So maybe the program class will make it easier for everyone to understand. So why I did all of this is basically so I can create this trainers list. So right now I'm having this only one implementation of random forest in ML.NET, but if I have a different ones, for example, I don't know, using some specific implementation of decision trees, or maybe using some different approach. So I might not want to use this fast forest. I can use some other trainer model, and to do that, all I need to do is create a new class in trainer, in trainers folder, inherit this trainer base, and use a different model here, and of course give it a different name here. But that's like really minimal changes if we come in that kind of situation. And also this approach gives me ability to inject different kind of hyperparameters here. So yeah, I can easily create new classes with a new hyperparameters, which is something that I've done here. Finally, for each model in this class, I call this train, evaluate, predict method, which is essentially training a model that we have in a list. Then we are evaluating it, printing out all the basically all the relevant metrics that we want to have. And finally, it uses a predictor to predict the value of this new sample that we pass here. So how that looks like, I'm just going to run it real quickly. I'm doing this in Visual Studio Code because I wanted to show that you can use notebooks here, but you can do it in a Visual Studio as well. So here is the output. So basically, for each class that we written here, we are having like information about which one do we have. That's the name part, where we use the name of the trainer model. And then there is the list of like metrics that we get for that one, that particular model. And also there is a prediction here. So in this particular case, we can see that this one says that we don't have a Delia class here. So it's a different class, while others have told that, this one says we have, and this one says we don't have as well. And so this one says we have a Delia class there as well. Now we can move further here and analyze these metrics and see which one performs the best, and further investigate each model and which one of these actually do we want to use. So this would be like the implementation. Do you guys have any questions so far? I would like to answer some if I was maybe too confusing somewhere.
Well, I have some questions.
Yes.
We've sort of invested a lot of time and effort kind of creating an AutoML inside of our tooling. And I'm wondering how we could maybe share that with the community in a way that helps it, so that you kind of don't need to create your list of trainers and stuff here. So like right now we're kind of going on the path of a config-based training. So in the config, like ultimately our end goal is making it so that, with the config, you'll be able to specify, if you want to, what algorithms you want to try and what sweep space, like what range for those hyperparameters you want to try. Do you prefer sort of like a code-based AutoML like approach like you're going with now over a tooling-based approach?
Well, this started basically as my exercise. So I just wanted to see if I can, code it. And there are a lot of like points where this can be improved, which I guess you guys already are doing in the tooling. So as you mentioned, the hyperparameters, we can add some kind of hyperparameter tuning here or something like that. But if it doesn't exist, if it already exists in the tooling, then it's already, you don't really have to do it. To be honest, I just did this part because it made sense for me to do it. All right. So basically, I prefer coding approach because I'm a coder, right? And that's just how things are, right, with me. But I'm guessing that having a tooling is a proper way to go, right?
Maybe, yeah. I think that's kind of why I was asking. I definitely like the code-based approach. It kind of shows people, this is essentially a more complicated version of this is what's under the covers in our tooling, right? Where we're going through a list of algorithms and we're trying to find the best one. And I think I like the code approach that you have because it makes it really sort of clear what's auto about AutoML, right? Like it's kind of just a magic loop to try out different things and evaluate them and see what the result is. So I sort of like the transparency of this. And I was just kind of curious, like you said, for a learning exercise, it's great, but it might also be good for our other customers for showing them how things work.
Yeah, of course, there are a lot of things that can be improved in this solution. For example, what I don't like is basically this, for example, loading and preparation of data and build data processing pipeline. I think that can be like a separate class that does its own thing, right? Like separation of concerns, proper separation of concerns. Then in the program, like these parameters, we can use like random search or something, which would be cool if if you're looking for something. I would like, for example, if I had that algorithm exposed to ML, and then I can like say, all right, just use new random search over these numbers, right? Which would be really interesting. But going with it sounds like a proper product, like going with configuration and then just adding config and it does everything for you, right? It sounds more like a product, and this is more of a, I guess, hacky approach. I don't know.
I think it's great. I love the code first approach. Like from our perspective in the tooling, everything is actually still the code approach. So I think that's how what makes sense to me as well. But cool.
Okay.
Yeah, thanks for sharing. As we're going through this, sort of building out our AutoML and stuff, I might connect you with one of the developers on my team, Shayan, who's also really passionate about this space, and maybe there's some code sharing that can happen. You can give us some insights into what you like there.
Cool. Yeah, that would be awesome. That would be really interesting. Yeah, thank you. So yeah, that would conclude my presentation regarding the code. So if you have any other questions, maybe regarding
I had one more question. So
sure.
You said you were using checkpoints in here.
Yeah.
Did you notice that it gave you any sort of performance improvement, or can you describe a little bit why you added checkpoints or what they do?
Yeah. Well, I wanted just to cache it here. I didn't measure it really. So yeah, another thing that I could probably add to this solution is some kind of like timing and see how fast the training goes, and if this actually improves it. It just made sense to me that actually just after the data processing pipeline is built, just cache that and then go from there. But I didn't use actually any kind of stopwatch to actually time the performance, right? Yeah.
Cool.
But that's a really good question. I guess I did that like with the blinders on. So yeah. Yeah. Okay.
It could. I'm actually not sure of all the best use cases for it. It's something that I'm still learning about with ML.NET. I'll reach out to Michael to learn more about him. He's the main developer over on the ML.NET side of things. So I might report back in the future if I learn more about it.
Okay.
And you mentioned, doing it with blinders, but that's part of the process with ML, right? It's about experimentation, seeing like, what works better. And, if it just so happens that so one of the use cases for the append, for the checkpoints, right, is if you have a small and like within this space, like small is basically whatever you can fit into memory, right? So it's very, there's no clear cut of what small is. But if you can fit into memory, a append cache checkpoint might be beneficial there. So like, like maybe sometimes, like you said, if it's a data set that is small enough that you can cache in memory, then maybe you may get those improvements. If not, you may run into issues. So yeah, but it comes back to that, right? And the AutoML and all these sort of, practices where it's a lot about experimentation and just trying different things out.
Yeah, why it made sense for me is basically because I plan to run the training on a lot of models, so it made sense to just push the data set in the memory, and it's not a big one as you mentioned. So yeah, it just but I didn't like investigate it so much. That's why I say I went in with the blinders. So it just made sense to me, and I did it, and it worked. So I guess it's a good thing, right? Yeah. Anything else?
Yeah, we've got a question. Oh, Luis, go ahead.
No, go ahead.
Oh, I was saying we got a question in the chat here. Can we do all things that we can do in Python for ML? I mean, pre-processing, training, and validation. Yeah, go ahead, Nicola, if you want to answer that.
Yeah. Well, we can. Yeah. So basically, in the trainer-based class, I've added this a part of pre-processing, right? Is I'm just using normalization here, but we can basically pick the features that we want to use and use them, and use like other types of transformers like key to value and value to key. So we can basically do all those things here. I did it in Python because, yeah, I just wanted this visualization here, and then I use it, to just import it. So I didn't do anything smart. But these things regarding pre-processing and training and validation can be done. I didn't actually compare like different metrics that we have in ML.NET and in sklearn, for example, or something like that. But yeah, I think the ML.NET is going with a practical approach. That is, I mean, these guys can confirm, but it seems to me that they are like going with things that are like already established in the ML world. So yeah.
One thing to add to that is most of the things that you have in your notebook could actually be done with .NET. So there is a similar charting library. The name is escaping me. Maybe Luis does, or Bree. But so you can do almost all of those things. I was trying to think if there was any of them that you did. Can you scroll back through that notebook?
Yeah, sure. So basically, it's just a scatter plot, and yeah, nothing. Basically, just removing the unnecessary features that I didn't want to use, and yeah, making like sorry for scrolling too much, but here like making this like value 0 and these values are 1. So it absolutely can be done in ML.NET as well.
Totally. So I wasn't sure if that's where that question was going, but yeah, you can do this stuff with .NET as well. And Bree posted, or Luis posted this earlier about the notebooks inside a VS question. If there is something you want to be able to do in notebooks that you're used to being able to do in Python, but want to be able to do it in .NET or want to be able to do it in Visual Studio, feel free to comment in there, share if you get blocked on anything. It's something we really want to light up, because especially for the cases you kind of outlined here, like data prep and kind of understanding your data and visualizing your data, I feel like Notebooks does it really well. And we want to offer that to our customers where they are in VS and in VS Code.
Can you just, yeah, sorry, I have a question actually. Can you repeat the name of the library for the visualization for the
So
.NET?
the one that you want to take a look at is plotly.net, and it's actually maintained by the folks over at Plotly. So it's there's also XPlot, which also works with Plotly, and that's a really good solution, and it's been used heavily, even in a lot of samples. But that is a community, not there's nothing wrong with that, but it's a community maintained, whereas Plotly.net is a project that's actually maintained by the Plotly team, the official team.
Okay.
Plotly.
Didn't know that. I learn something every time I talk with you guys. So,
yeah. Yeah, next time we see you, we'll have to see all the stuff you did in Python. We'll have to see that in .NET
of course.
next time.
Yeah, no problem. No problem.
The one other thing I wanted to mention kind of around data prep is that .NET DataFrames just moved from the core FX Lab repo to under ML.NET, or the .NET machine learning repo. So we plan to do some more work there as well for data prep.
And for folks who may not be familiar with the DataFrame API, that is a .NET API that is very similar to Pandas, but it's using .NET. So if you use Pandas and you're familiar with Pandas, the DataFrame API will feel very familiar to you if you're if you want to do that in .NET.
Okay.
Great. Any other questions? Post them in the chat, or obviously Louise or Jake, if you have anything, or Nicola, if you have questions for us.
I actually have a question. So you mentioned that because this whole Python talk, and you did some of your data prep in Python. It sounds like you do quite a bit of work with Python for in your work. How did you start using ML.NET, and why? What got you started?
That's actually an interesting story. Basically, I'm a .NET developer, so I learned Python because I was interested in machine learning. So it basically made sense then. It was quite a while. So it was basically the only option out there. I mean, there was R, but I was not up to learning R. So yeah, I just went with Python. It seemed like it had more libraries, right? And then actually when ML.NET 0.01 first like version was out, I've done like I think that the blog on the bike demand is based on one of the examples I actually contributed to the ML.NET open source. So yeah, it was really cool seeing that it ended up there, and yeah, so that's how I started basically. Yeah. So
Awesome.
I basically I'm a .NET developer that got into Python just because of the ML, and once there is an option in .NET, of course I'm going to use it. So yeah.
Very cool. Is there something in the I guess in the that's currently either not available, or some things that you think that you like to eventually see?
Yeah, well, that is something that I wanted to actually show you what I'm working on at the moment. So there is this like brief concept that I plan to do, and because I need like a BERT model which I want to build in PyTorch and transfer it to TensorFlow model. Basically, my team is working on a BERT model using PyTorch, so I just want to transfer it with TensorFlow, and because I want to use it with ML.NET inside of microservice, because we are using everything. Like everything is .NET based, and we're using Azure and Azure Kubernetes services for that. So yeah, that's something I'm planning to do, like automate that training process. So I'll if you have any ideas how I can do that and improve it, I would like to get some feedback as well. But also I will let you know how it goes. So basically the whole automation of the training process, the tests and everything with ML.NET. And yeah, so probably here it would help me if I don't have to transfer it to TensorFlow model, but like don't use Onyx, right? So I can just go straight from PyTorch to ML.NET. I guess, yeah, that makes sense from the industry perspective as well, because I think more and more people are going to PyTorch actually, because it's faster for training. So yeah.
Yeah, we love to see what the results of this project are, and we love to hear more, and maybe even if you're able to share at a later date, have you on to talk about that project on the stream.
Yeah.
We do have. Yeah, sorry, go ahead.
Oh, I was just going to say, this is something that's on our radar. We know that BERT is popular. I'll need to follow up with some of my contacts. I know that there's work to make it not necessarily in PyTorch or TensorFlow to get it into ML.NET, but actually sort of the Onyx route, like creating. I forget exactly the details of BERT, but I think there's like a way of featurizing the data that you need to do something special for before passing it to the BERT model. And I think that most of there's already the BERT model. My understanding is that it's already available or converted to Onyx, but it's the featureizer that may or may not be available yet, and that's what they're working on. But essentially, we're working with our partners to figure out what the best way to sort of bring that to ML.NET is. I don't know what the timeline of it's going to be, so if you beat us, we'll definitely leverage your work. But yeah, sure. I can try to connect you with folks on our side and make sure we're kind of moving towards a similar architecture if we want to be able to leverage each other.
All right. Yeah. Thank you for that.
For the data lake portion, how are you connecting your data to ML.NET?
We are still working on it. So yeah, I cannot really give you like a concrete answer yet. So yeah,
that's
we're still in the process.
On our roadmap. So
Yeah, that would be actually great. Yeah, I understand your question now. Yeah, that would be great if we can just connect it to the model. That would be like amazing, right?
Cool. Thanks for sharing this.
Yeah, thank you. So yeah, I don't have anything else. So if you guys have any other questions for me, please feel free.
We're actually at time, and we really want to thank you
Wow.
for showing us the demos that you did and your process around building these blog posts, which is really great. I think a lot of folks will get a lot out of that. Certainly we had somebody in the chat, Bimal Kumar, asked, what are the basics of learning ML, and I added to the chat. I would encourage you to check out John Wood's videos, as well as Nicola's blog post here from Rubik's Code. Where he talks about the different, scenarios and things like that. So make sure to check those out. So with that, I just want to again thank you, Nicola, for coming on. We really enjoy showcasing some of the work that you're putting together. And again, every time we love to have you on to show maybe this project that you're working on now. Until next time, folks.
Thank you, guys. Thank you. Have a good day.
Thanks.
Bye.
Thanks.
Bye.
See you.
Bye, everyone.
Bye.